Class, today I'd like to give you a little presentation about why details matter to tech careers. I've noticed over the past few weeks that there's been a pretty continuous problem with people not paying attention to details, and I think a lot of you must not be comfortable or familiar with classes where these details really matter, where you need to read the instructions twice and then a third time again. So I thought I'd go into that a little bit more. Why does it matter? Why is this realistic? Now, in life, some things don't matter. Details don't matter. The common ones are horseshoes and hand grenades. Details don't really matter. I've also got a friend who is a professional yarn artist, and she makes different knitted items, and I'm pretty sure that if she made a mistake in there, it really wouldn't matter, okay? A few little yarns out of place, it's not going to detract from the overall work that she's doing. But computer science and software, it is not one of those things where details don't matter. I remember when I was going through college, my professor mentioned a couple of different things that actually happened, and I've looked into these, and as far as I can determine, they did actually happen. So when the F-16 fighter was first designed, it was a, quote, fly-by-wire jet fighter, so everything was done in computer. And there was a very fancy simulator built, and when they first flew the F-16 over the equator from the northern hemisphere to the southern hemisphere, the entire plane flipped upside down. Somebody had a software error there. Fortunately, it was caught in simulation before it actually caused someone to die. But that's the kind of little bug that, someone probably didn't read something somewhere, didn't pay attention. Also in the 80s, there was a first-generation radiation machine for treating cancer called the Therac. And this machine was actually used in the Seattle area. It would occasionally give patients lethal doses of radiation. It would occasionally give them severe burns, but the people swore up and down that it was fine. There were actually errors that would appear on the screen of the operator, like error 21, would you like to proceed? And then the operators would just go ahead and proceed. But those little errors were actually causing severe radiation overdoses. A little bit farther on, the NASA Mars Orbiter, a $125 million satellite, was lost simply because there were Americans working in English, there were Europeans working in metric. They knew that they had to convert it, but somewhere along the line, somebody dropped that, and that led to the entire loss of the orbiter. In software, these little tiny details written in manuals that the programmer has to follow, these little tiny details are very important. And it is absolutely real life to say that you have to read your instructions, you've got to write your program, you've got to make sure that you've read the instruction carefully, and then before you're done, you need to read those instructions again, okay? And in real life, actually, the instructions will change between the time when you start the program and the time that you are done with the program. So you need to continue to read those details. Wouldn't that be even fun if I just kept on changing the assignment on you? So the cost of software errors is somewhat unique. When you build a house or when you build a car, if you make a mistake somewhere along the line, it's probably not going to be a whole lot more difficult to find it later on than it is early on. But in software, it's almost always the case that the bug becomes much harder to find the later you get in the development phase. It takes about half of a development cycle to write your code to what we call code complete, but it takes fully that same amount of time to get it debugged. So even though you've already written 99% of the code, why does it take that last 1% to take half the time? It's because bugs are much harder to find when the product is complete than if you did it at every little module. And the way I'm trying to teach you is to try to teach you to, for example, in some of these projects like the calendar, I'm trying to teach you, let's develop 1 month's calendar. Let's debug that. Let's debug it thoroughly. Then, only then, should we start printing out all the months. Because if you don't know that the single month works 100%, it's going to be much harder to try to figure out when you're trying to print out 12 months. There's a whole book called The Mythical Man Month that it goes into the theory back in the 70s and 80s. Well, if the project is going to take 12 months, why don't we just put 12 times as many people into it? We'll have 12 times as many man months. We should be able to get the project done in a month. Well, it's largely because of bugs that does not work. You can't just throw more people at the problem. The more people you throw at the problem, sometimes the worse the problem becomes because you have more people putting more code into the project, introducing more bugs. I'll give you two simple examples that I personally know of in my programming career. One is a very common bug called the buffer overflow. Buffer overflows have been responsible for a huge raft of security problems. Basically, a programmer doesn't account for how many characters or how large of an input a user might be providing. And you can take advantage of that and be malicious. But I remember an example early on in the Excel days where the entire project was ready to ship, except for this one incredibly difficult to reproduce problem. And they ended up bringing in what's called an ICE machine, an in-circuit emulator. And they had to hook this hardware level machine into a computer and run the program until it finally crashed. And then they could actually step back microprocessor instruction by instruction to see at what point it crashed. And the reason it crashed was because of a buffer overflow. Okay, someone had written too many bytes into a buffer that was thought to only have to handle a certain number of bytes, and that completely overwrote the code and led to the program crashing. Another one in my personal development, someone on my team, they were in charge of synchronizing multiple threads, and that's not something that we're going to cover in this class at all, but almost all software these days is written with multiple threads. So you have multiple programs running at the same time, and when those threads are working on the same data at the same time, there's some very intricate dances that need to happen there in order to coordinate those threads. And he didn't debug it well enough when he first wrote it, and so occasionally the entire program would just crash, and it was almost impossible to debug that. And we really had to almost completely throw everything out. We had to do an entire new revision of the code before we could get rid of those bugs, and I had to bring another programmer in. So the cost of software errors really escalates exponentially as the farther you get down the program. So what I'm trying to teach you is you have to read the instructions before you begin your work. After you've figured out what you're going to do, read them again. Make sure that that's really what you're supposed to do. And then before you submit your project, read them a third time and check that all the little details have been followed, that you've submitted the right file, that that file has exactly matches the output that's been given to you, that you've included all the necessary cases. You really want to make sure those little details are followed because details matter in programming. So let's talk a little bit more about mistakes. I know that some people would like to take a shortcut in this class and try to do things right the first time, or just turn in always 100% A material. That is not what programming is about, okay? The difference between an amateur and a professional, I have learned in life, is that an amateur hasn't tried it or tried it just a little bit. The professional, what makes a professional is that they have tried it and failed miserably, and learned from it. When I hire a plumber, I actually want a plumber who has flooded somebody's house because he knows all the ways you can flood a house and he will never make those mistakes again. So in this class, don't shortchange yourself. Don't think that you will be a better programmer if you always do it right the first time, or expect that you can just do something like learning to program nested loops once and that you've got it. You need to let yourself make 100 errors. You will learn more. You need to space that learning out over a long amount of time and continually go back and learn it again. Your brain needs to build synapses for all these different things you're learning. Each time you go and refer to, gee, how do I write that nested loop? Your brain will strengthen those synapses. And eventually you can do it without even thinking, okay? And one thing you can do to really help yourself is do more practice its, okay? I assign you the bare minimum to check to see if you're having problems with practice its. If it takes you more than a couple attempts to get something right, then you really need to try other practice it problems and learn how to do it. There is a wealth of practice it problems available to you. And you will be getting extra credit later on in the quarter for how many extra practice it problems you have done. But the extra credit, the value is not really in those few points that I will be giving you. The value is that you will be learning more, okay? So why do we go through all of this pain to get all these details right? Well, it's because there's a huge number of tech jobs out there. So really quickly, there are about 250,000 tech jobs in Washington State. 90% of those are in the Seattle area. And it's not like there aren't more tech jobs that they're making every day. There are 50,000 job openings in the Seattle area. That's a number I pulled out of the newspaper. I actually think that's low. I remember when I was working at Microsoft, we had 25,000 job openings just for Microsoft alone. So I'm pretty sure that there's probably more than 50,000 job openings. 1 in every 6 tech jobs in the entire US is in Seattle, okay? So also that shows you there's a lot of other tech jobs outside of Seattle. And I have a nephew who graduated from the UW Computer Science Department about 4 years ago. And at that time, he actually showed me the starting salaries that were reported by his classmates. And they were generally around $100,000 a year. So that's fresh out of college with a Bachelor's of Science degree, $100,000. And I know lots of software developers whose salaries go up to $180,000, $200,000. Okay, so not everybody's going to earn that much, but that's why so many people want tech jobs. So let me tell you some more about the careers in tech, because it's not just all about programming. So I'm somewhat familiar with all of these jobs that I listed here, because I actually used to be the manager over all of these groups of people. I had about 70 people that I'd hired, and I had software design engineers writing the code. I had program managers helping develop the specifications. I had test engineers making sure everything was working right. I had user education people writing the manuals. I had localization people working on a raft of different languages. I had marketing people telling me what kind of features we needed to put in and making sure that those features were loved by the customers and that we were going to be able to sell our products. So I'm going to go through each of these in a little bit more detail. So nearest and dearest to my heart is software design engineer. I was trained received a Bachelor's of Science in computer science. I got a Master's of Science as well, and I spent a long career at Microsoft. Generally, we look for people that have a Bachelor's of Science degree, but also math and physics are very common, electrical engineering as well. So these people, of course, write the code. They're doing exactly what we're learning to do in CSC 142. These people need very strong technical skills, okay? And how do we determine they have strong technical skills? Well, I'll tell you a little bit about the interview process. And of course, it may have changed somewhat since I left, but I've been keeping up to date through people such as my nephew who've gone through this process recently. So there's your resume is submitted online, and then there will typically be, oftentimes, depending on the size of the company, an online interview portion. So you'll go on to an online site just like we've used with Practice It, and they will give you a coding problem to solve, or maybe the interviewer on the phone will give you a coding problem to solve, and that'll typically be done offline. So you do it on your own and then you submit it. Now, I should warn you that this is very much like the situation we have in class here. If you choose, obviously you can cheat on that, right? So if you choose to go out and cheat and submit somebody else's code, what's going to happen next is an in-person interview, typically on phone or in person at the facility. And if what you turned in doesn't match what you can show in person, then nobody's even going to give you a second thought, okay? You will be out of there before you before you can finish your bottle of water, okay? They will kick you out the door so quickly, it'll just make your head spin. So I am teaching you a very valuable lesson about how the industry works when we do these video conferences. When I see people that have an inconsistent performance for what they've turned in, it's a red flag to me. It's not very difficult for a trained interviewer to spot whether someone really knows how to code or not. I'll also say that the interview process, you would think that every single person who graduates from MIT or Stanford in computer science would be an excellent coder, and that is actually not the case. I have interviewed tons and tons of people from MIT and Stanford, and quite frankly, most of them can't code well enough for Microsoft standards. But on the other hand, a lot of people who maybe even haven't graduated college, but really are good coders, they pass the standards with flying colors. So it's not about where you went to school, it's what you know. And it's not about what you've done or what you can turn in or what you can point to on your degree, it's what you know, okay? So let me move on to other roles. Another really important role is the program manager. A program manager is not something that most people are familiar with outside of the computer industry. It's about 50% writing specifications, so writing big books of documents, and 50% meetings. Typically, we see people who are interested in computer science but don't really want to be programming or don't have the skills to be programming. They, in a few schools, they actually have user-centered design degrees, but not many. But we usually look for people with STEM-related fields. So the spec, when I give you a problem set, I give you a lot of written documentation for how the code should be written. That's very similar to what a program manager does. They produce literally book sizes of volumes of documents for a spec. On every version of Excel, the spec might look like a telephone book by the time it's done. So, and I said the other half is that there's a lot of meetings because the program managers have to coordinate with the developers, the testers, user education, the marketing, pretty much everybody. They spend probably half their lives in meetings. So you really have to like running meetings and having strong interpersonal skills. There's a lot of dispute resolution. You have to be very good at tracking the project. So someone who drops details is not going to do well at all in this job. Also, someone who can give a lot of presentations. So that's a program manager. A lot of people think of the program manager, oh, they run the whole program. That's like they're in charge. No, that's not actually the case at all. Program manager is just another facet of the job. Test engineers. I've heard rumors of test engineers' demise at Microsoft in favor of having all software developers write their own test code. But I imagine there's still a job for testers in some way. Testers typically have a Bachelor of Science in any field, and it's a little bit hard to find testers and interview them because on the one hand, you want someone who can write code because testers write the test code that drives programmers' code and makes sure that it's all working. But they also do a lot of manual testing, and so we have to determine just how well do they know a program, how well do they know programming, and how can they manipulate that to be able to figure out where is this program likely to test. So whenever I give you assignment, I kind of have in my mind a few ideas of where people are going to go wrong with their programs. And a good tester understands where those things can go wrong and they know how to attack them. So test engineers, even if Microsoft isn't hiring test engineers anymore, all other program employers should be hiring test engineers. So a test engineer still needs to have very good technical skills. They need to be able to write code, but not as well as someone that they hire for programming. And details definitely matter with test engineers. Okay, user education. So we need people who are going to write the instructions and the help and the user interface. So typically we look for people with liberal arts degrees. They need to be very good technical writers. They oftentimes interact with the users. They test them out. There's the kind of room with a mirrored wall, and they sit behind the wall and they watch and see how people interact with the programs, and they figure out what goes well and what doesn't go well. And then they work with all sorts of groups. They typically work with the program managers and the programmers to get all this done. Localization. All Microsoft products and products these days are localized all over the world. So typically we're looking for a foreign national with good English skills. Products are at Microsoft, they're usually written in English first, then German, because German is the longest language of all the non-double byte character system languages, and then Japanese, because Japanese is one of the most popular double byte character systems. Maybe these days it might have switched to Chinese, but generally Japan is one of our biggest markets. And then after those first three languages, the programmers work with localization to make sure all three of those languages work. And then after that, they pretty much turn the entire program over to localization. Localization then needs to be able to put in dozens of different languages and make sure that it works with all these different programs. They need to have very strong technical skills. Sometimes coding is required because little things might need to change depending on specific language requirements, but these days we try to make it so that we can put any language into a program. Marketing. So we're looking for people with experience in sales and marketing. They're going to develop the needs from the users. There's lots of research. Again, those mirrored walls where they have users on one side and they're observing them. There's a lot of customer contacts, either flying out to various major corporations that use our products, or they might come to Microsoft and visit. And they do the marketing of the software to the users through print and online advertisement, through a lot of trade shows, through a lot of client visits. And very strong interpersonal and written skills are important for that job. But also details are important because there's a lot of details going on about, just how does the program work. When they go and visit clients, the clients are going to ask them very technical questions, and they need to be able to come up with an answer. It doesn't look very good if they don't understand the product themselves. So details matter in the tech field. Your career success depends on your attention to detail. So as frustrating as it might be to have to read the instructions 3 times to make sure that you turn in all of your files in the exact right format, this is what the tech field is all about. So I'm trying to teach you many different skills here, including programming, but also high attention to detail, interviewing skills. So all of these things that you're learning in this course are going to be important if you are going to try to get a job in the tech field. And really my goal in teaching this class is to try to find someone who can someday replace me and the work that I did at Microsoft, someone who can fill those tech jobs that we have available, but for which we are not generating enough computer science grads. So good luck to you in the tech field. The number one thing I would recommend is pay attention to details. Thank you very much.